Alright, hi everyone. This is weekly contest 509. Uh, I hopefully I'll do well on this one instead of the previous one. And it's also 4th of July, so happy 4th of July, everyone. Uh, I'm in US right now, so let's go. Sum of integer with maximum digit range. Integer enums. The digit range of an integer is defined as the difference between the largest and the smallest. Whose digit range is equal to maximum digit range. Int answers -1. Int x nums. Int min is equal to 10. Max is equal to -1. While x min equals min x mod 10. Max equals max x mod 10. X divided by equal to 10. If max minus min is greater than answer, answer equals max minus min. Int rest is equal to 0. Rest equals to x. Turn rest. What happened here? Oh, rest equals to TMP. 5724. What happened here? Max min is 10. 0. Oh, wait. Maximum digit range is 5. Oh, okay. Else rest plus equal to TMP. Can I go to long long? No. 6185. Else if max minus min is equal to answer. It's kind of slow for A, but okay, okay. Subsequence after one replacement. You are given two strings S and T consisting of lowercase English letters. You may choose at most one index in S and replace the character at that index with any lowercase English letter. Return true results to make as a subsequence of T, otherwise return false. 10 to the 5. Okay. So if it can be subsequence of T, pineapple is false. P A, yeah, okay. C A T. What? Um, S can you can delete one character from S. C A T. So from A to H, C to C. Okay. E can be matched in T, but the remaining letters cannot be matched while preserving the required order. Even after placing any one character in S, it's impossible to make S a subsequence of T. The physical game. Subsequence after one replacement. So you can replace a character in S, and then it's asking you if it can become a subsequence of T. Cat, chat. if it can become a subsequence of t. So suffix, prefix. Size, m is equal to t dot size, ref n, int, for int I is 0, that's more than n, I plus plus, int j is 0, while j is less than m, and tj is not equal to si, j plus plus, pref I is equal to j. If it's m, it's just not possible. Okay, and then j plus plus. Okay, also need a suffix, int, 1 at 0, or into j is 0, j smaller than m, no, so j is m minus 1, or int I equals n minus 1, I greater than 0, I minus minus, while j is greater than equal to 0, and he, I, is not equal to sj, j minus minus, pref I is equal to j, if j is greater than equal to 0, j minus minus, stuff. Okay, for int I is 0, I smaller than n, I plus plus, if pref n minus 1 is not equal to m, or stuff of 0 is not equal to negative 1, return true. So otherwise you have to change something, so choose to change I. Okay, pref. So this is the ending, right? It's the ending. If I is 0. Okay, well actually we'll do this. Stuff 0 is equal to negative. How do you do this one? Sub I, sub n is equal to m plus 1, and pref 0 is negative 1. Int L will be equal to pref I. Int R will be equal to sub I plus 1. And if T contains this integer, if L is less than or equal to R, if less is less than or equal to R, if S is less than R, if S plus 1 less than R, return true, return false, true, false. Dang it. Q O Q. Is it this one? Yeah, it's probably this one, right? Pref I. Prefix 0. Oh, wait. Pref I plus 1. Wait. No, it is pref I, and then this is sub I plus 1. And sub n over here is m, so it's 5. But over here it's 4, but it should work. What happened? Okay, somehow I'm actually doing okay right now. Oh, over here. Oh, because we forgot to change this. It's pref and sub-zero. X 324. What about this? 300. Okay, so that barely changed anything. Oh, I can't see the non answer. What test could it fail on? Okay. XC, XS, and this. Output false, answers true. Yes, came over here. Choose to change I. We should choose to change this X. If we choose to change this X, so 0, 0, and over here, so over here, this should work. Unless I made some other mistake. 0, -1, -1. So 1, -1. Uh, S. J is greater than 0 and Ti is not equal to Sj. Oh, wait, Tj. Tj and Si. True, false, false, true. Okay, that was really bad. The divisible game, you are given an integer array nums of length n. Alice and Bob are playing a game. Okay. Alice chooses. How am I doing? 10 minutes. 20 minutes. Okay. So I got keep quite fast. Uh, K and L and R scores are 0. Number divided by K increases, otherwise Bob's score. Alice's score minus Bob's score. Maximize the score difference. If there are multiple values of K that achieve the maximum score difference, she chooses the smallest possible K. K. Product of the maximum score difference and the chosen value of K. Since the result can be large, output module. So we have a mod. 29 plus 7. If nums I is divisible by K, Alice's score increases by nums I. Okay. So it's the number that are divisible minus the number that are not divisible. Uh, Product of the maximum score difference and the chosen value of K. 1,000. Nums.length is 1,000. Can we use a sliding window? Like, well, we can, if we choose K equals 1, it will just be everything. And then if we increase K, wait, can you choose, oh, K is greater than 1. Okay, gotta choose K is greater than 1. Score is 0, all pop scores 1, -1, modulo 10 to the 9 plus 7 equals this. Okay. So basically, you choose a range, you choose a K, and if K divides, so count the number that it's divided, versus the number that's not divisible, and then the current count is the subtraction of those. If we have a k, can we find a sensor quick? K is 10 to the 6. 10 to the 6. So prime. We only need to choose prime k's. Number of primes under 1, 10 to the 6. Where is it? Where is it? 1, 2, 3, 4. This is 50,000. 0, 1, 2, 3, 4, 5, 6. So about 1 e5. I'll just use 1 e5. 10 to the 5, we can't multiply 10 to the 5. Oh, wait, 10 to the 5 times 10 to the 3. But, we add another luck factor, so I don't think that'll work. Can we use a set of, primes? Here's 1,000 times 100. 100 primes? No, 10 primes, probably. Or something. So, that's 10 to the 4. I'm not sure it'll work. It's probably easier. What is this? Maximum sum of separated nums as a palindrome. Palindrome. Okay. Given an integer array nums of length n, Alice and Bob are playing a game. Alice chooses an integer k, so that k is greater than 1. Nums be volume. Okay, so the question is how can we get the answer for a single part of an array quick? So the answer for this, can we do it in ON? It's probably ON squared, so iterate over the R values. So first is 1, and then it's 1, 4, and then 1 for 6, and 1 for 6, 8. And for each one, I think calculate it in ON. First we get to 1, and then we just choose 2 for it. And then we get to 4, and then we'll still keep choosing 2 for 6, same thing, 8, same thing. 1468. Max answer correct here is 10. This kind of obvious. Over here. 2 and then 2 1, 2 1 2. I don't see obvious solution. Otherwise than using like a secretary. 10 to the 6. So again factoring logarithmic time. So 1000 times log of 10 to the 6. What's log of 10 to the 6? Log 10 to the 6, 2. 2, 3, 4, 6, 2. Nah, 20. So 20 times that. So 2 times 10 to the 4. 2 times 10 for 4 for each value of those. 2 times 10 to the 4 times, so 2 times 10 to the 7. 2 times 10 to the 7. 2 times 10 to the 7. Okay, so 2 times 10 to the 7 times a log factor times 10. I will try it, okay, because I have no idea how to do this otherwise. It is a medium though. To 6. We'll need a prime sequence. No, I'll go ahead and try to do something that's better, guys. Palindrome. Okay, so key thing is palindrome, right? Um, so over here, 7 1 7 1. Now we have a 2, and now we have a 1 7. So ON cube solution is easy. I think you can go from one palindrome to get another palindrome, right? Yeah. For each index, if we see a palindrome for 4, we have 4, and then we get 3 3, right? For 2, we have 1 1, 7. So we have ON squared solution. Okay, ON squared solution. Um, might have solved it. Don't know. There are multiple values of k that achieve the maximum score difference. She chooses the smallest such k. Return the product of the maximum score difference and the chosen value of k. Since the result can be large, return a modulo 10 to the 9 plus 7. For a fixed right index, calculate the value of the current. Can choose to not use or use. Okay, let's try it. -1 E18. -1 E18. X, case 1. Um, try to use X. Right, try to use it. So, for all the factors in it, you get a new answer based on the previous values. Okay, with 1. Now we're stuck. Answer is -118. For int X in nums, try to use X. So get the answer if we use X, basically. Can you only use prime divisors? And for int plus 2. Um, can use a C. Okay, this should work also. Map 2 plus equal to TMP. Okay. Um, yeah, okay. For int I of 3, I times I is smaller than equal to x, I plus I plus equal to 2. If x I is equal to 0, while x not I is the 0, x divided by equal to I, map tmp, map I plus equal to tmp. Okay, so if um, long cur is equal to mp2, 2 times mp2 minus sum plus equal to x. If current or current equal to answer and 2 is less than pre-k, answer is equal to cur, pre-k is 2. Okay, so this is the same thing over here. Answer times pre-k. Answer plus equal to mod, answer mod, y by mod. 34. Close. Okay. Oh, because we can choose when we stop. Okay, we can choose when we stop. The limit of min map. Okay, map 2 plus equal to tmp. What is min map? What does min map do? Numbers, all the prime numbers in the primes that don't divide can remove. Okay, so what do we do over here? Map int long min map. This should be the minimum of the prefixes for a single prefix. Yeah. Min map p dot first equals to min map p dot first p dot second minus sum, right? 34. So p map min map p dot first equals to min map p dot first p dot second minus solve. It doesn't account for 2. 7 is not equal to 26 plus I have 10 c 0 if c I is equal to I, when j is 2 times I, j is not equal to 26, j plus equal to I, sieve j is equal to I. Yeah, that's our sieve. 48 xing nums, y x squared 1 into c prime c x equal to p, and map p equals x p a, okay, or 8 times 0 multiplied by 1 plus 8 n equals nums dot size uh, not mp.count p. So if map is not counting p, right? And otherwise, plus equal to p. How do you do this? MPP, PP plus equal to 0 plus this nums I. This should be over here. This should be the right one. But for the ones I didn't see, you also correct on it, right? This P, P is less than PQ. 6 plus 8, 36, 8, I don't know, how do we get 8? 343, 8, how do we get 8? It's because there were no primes, right? And then it broke everything. S dot count P, S, MPP equals max MPP minus AI, 0 log log, yeah, 343. Auto MP, EMP. If it's a 1, everything is deleted by 1. Oh, we didn't add that mate. This passes. Come on, TOE. Okay. Dang. Okay. I don't know if it hasn't updated yet, or I'm just doing horribly right now. But that was a pretty good problem, actually. I'm actually just doing horribly. Over here, doing at 34 minutes. Okay, I'm at 1,400. I'm at 1,500. Okay, if I solve the last problem, I can probably get up there. Okay, so just a palindrome problem. Where we have a palindrome. How many users is up to this? 744. Okay, for every index, we check. For every index now, try to check if it's possible or not. Right, so if it's even, right, if it's even, then we just choose two adjacent elements are equal and we spread it outwards. If it's not even, we choose one element in the middle and we spread that one outwards. We shouldn't get those two wrong answers on problem two. But, okay. There's 40 minutes left. Your task is find the maximum sum of a subarray of nums that is a palindrome. Return the maximum sum of such a subarray. but also a sub. Read those in forward and backwards. So, okay, so if we choose our middle pivot point, then we use OM time to check the rest. There's no mods for this. How do so many people solve it? Come on, can LM solve it? Palindromic servers. 2 consecutive indices. Take middle. One and the middle one. Okay, so if what do we do here? Find the middle of it. Two, three, four, five, six, seven. value. Try to make it a palindrome. Try to use this value to make a palindrome. That work. We use that. Um, so if we know a range can be made into a palindrome, then we can go on to bigger ranges. Suppose sums of indices. I'll make a subarray sum. For every length, we check the maximum. For some reason I'm thinking of a segment tree right now, even though it's not the answer. Because we need something with log n, right? We need something with a n log n. Have a m squared solution. A, a pair. But there's at most m squared. M squared. Right, that's the problem. We find the maximum sum summary of nums that is a palindrome. Return the maximum sum of such a subarray. A subarray is a contiguous non-empty sequence of elements within an array. A subarray is a palindrome if it reads the same forward and backward. Worst case is if it's all ones. Oh well, I'm at 2026. Are the LM sendings out? Oh, yeah. What happened over here? Did he not test these yet? So I guess the last problem is LLM. Um, Probably has something to do with. Oh no, actually. You're given an integer nums. Your task is to find the maximum sum of a subarray of nums that is a palindrome. Return the maximum sum of such a subarray. A subarray is a contiguous non-empty sequence of elements within an array. A subarray is a palindrome if it reads the same forward and backward. Forward and backward. I just have no ideas right now about what to do. Like, what do we do if we get a sequence all at once? Like, how will we find a efficient algorithm for this? And if we go from the highest length to the least long length, then what if their array is all distinct, right? We have nums as a palindrome. Turn the maximum sum of such a subarray. Subarray is a contiguous non-empty sequence of elements within an array. A subarray is a palindrome if it reads the same forward and backward. Alright, you know what? I think I will just go for the solutions right now. After contest is over, I'll look at some other people's solutions and then I'll solve it after. But anyways, I'm gonna start right now. So, problem one. Problem one, you only have to, it's just an implementation problem. The important thing is finding the digits, right? To do this, while x, and then the current digit will be x mod 10, and then x divided by equals to 10. And then we keep track of our minimum and maximum, right? If the difference is greater than our current maximum difference, right, we change this current maximum distance. And then the new answer will be equal to TMP or the original x. Otherwise, if it's equal to the current maximum, we can add it, right? And then we return our answer. Um, so this is just implementation, yeah. And then problem two. Problem two is you have to take the prefix and the suffix of the strings. So what I mean by that is, so pref I, right? We have this pref I. Pref I means minimum index in T. Pref I to J means J is the minimum index in T such that T0 uh, T0 to J contains S 0 to I 0 to I minus 1. So that's pref I. I'll go into details later, and this is stuff I. Means J is maximum index in T such that T from J to n minus 1 contains S I to n minus 1. Okay. So let's just say we have these, right? Let's just say we have these stuff and pref and stuff. What do we do now, right? First of all, if we don't need any operations, right? That means pref n is not equal to m, where I set m equals impossible, and over here is -1 is impossible. So if pref n is not equal to m, or pref sub 0 is not equal to -1, return true instantly. Otherwise, we have to change a index, right? So we make a loop over the possible index we choose. So currently, right, if we're at I, right? L L is um previous minimal index for S 0 to I minus 1. And R is uh, max index for S I plus 1 to n minus 1. Right? So we have our L and our R, which based on our definitions for pref and stuff, we get. Um, and then, so what this means is if there's a gap between them, right? If there's a gap between L and R, we can just change this current character to the gap inside S. How do I explain it, right? If we have cat, right, and we have CHHT or CHT, HHT, right? C over here we use this one, T we use this, so there's a gap of 2 in between. Because we have a gap in between, we can just choose any one of the characters and set A to it. So we can just set A to H or A to Y would be also okay. So if L plus 1 is smaller than R, return true. If there's no gap for all of them, then we can return false. And over here, right, the implementation for pref and stuff. For the prefix, we use a 2 pointers approach. So at the beginning, pref 0 is -1. We set it to -1. Because that basically means that we change the first index, right? Our pointer right now is at 0. For every position, while this pointer is not less than m, while this pointer is less than m and it's not equal to the current si, j++, and then pref I plus 1 equals j, right? We said it. And then if j is less than m, j++. Because if j is less than m, we gotta go to the next index. Stuff is almost the exact same thing except reversed. And yeah. Okay. Now I'll explain problem 3. So what happens here, right? So the approach I did it's kind of messy, but I basically take all the primes there are possible because K is always better to be a prime, right? It's better to be a prime than a non-prime because a non-prime can be split into multiple primes and we can choose one of those primes and it will be better. So basically, first I get all the primes. Well, I don't really get all the primes, but first I make a sieve. So this is a sieve for minimum prime. For example, right, minimum prime for 9 would be 3. So this sieve calculates that. And then for every index, right, so first we have a answer and we have a pre-k where the k we use, right? For every index, we try to use it. We have a set of the current primes. Yeah, so we have a set of the current primes. Yeah, the set of the current primes. So first we get the prime from our sieve, right? We divide equal to prime, and then we insert this prime to our our set of primes, and then we add this prime into our map. This map would be so map I to j means j is max answer for k equals I. Right here, right? So currently this would be at 0 because we just set it to 0 for now. Later we'll change it. For auto NP in map P in map. So for all of the current previous primes we saw, right? P is our current prime. If this prime is counted, if this if the current value is divisible by this prime, um then we can update our map. So map P will be max map P P. So MPP equals max MPP 0 long long plus AI, because it's we add this and we check if it is our new best answer. Otherwise, if it's not inside of here, uh, we can just update it by using if subtraction. So map P equals max map P minus AI and 0 long long. After all of this, we can use mods on our answer, and answer times pre-k divided by mod, because that's what the problem is asking us to do at the end. For the sieve, this is just a sieve for minimum prime. I kind of memorized it already, but all I have to do is you make the sieve from of the maximum integers, and then you iota that, right? For every I from 2 to 1e6. If sieve I is equal to I, this means that I is a prime. So you can update all of the rest of the values in sieve from 2i all the way to 1e6 plus equal to I, and then sieve j will be equal to I. So yeah, that's it for Q3. There's a minute left. Uh, right now we're at 3,000th place, but hopefully a lot of cheaters get caught. Okay, so 20 seconds. Just wait for it to end, and then I will get to solving problem 4. Alright, there. Right, how did we do it? Can't really understand that code, okay. Um, okay, so let's see. Prefix sums, right? So we make a copy, and then we do a prefix sums. Make a copy of the array, make a prefix sums. What does this do? Okay, this one's much more intuitive because it's written by AI. But prefix range sum, so the range, the sum of this range. For odd length, right? We have D1, okay. L is 0, R is -1, so I guess this is the range. For range I is 0, I is smaller than N, I plus plus. Int K is I is greater than R, it's 1. Otherwise, it's minimum D1, L plus R minus I, R minus I plus 1. Well, I minus k is greater than or equal to 0, and I plus k is less than n, and this k plus plus t1 I is k. Okay, I do not understand this. So what I'm going to do is I'm going to go to Leetcode, go to problems. I'm going to go to the most recent problem, and I'm going to see if anybody made some solutions yet. Manage your algorithm. What is this? Okay, I've never heard of this before. Um, Symmetry optimization. Initialize pi, palindrome radius of I is the mirror. This is R. After initializing pi based on symmetry, you plan to expand the palindrome centered at I by checking if the elements at I minus pi and I plus pi match. Build prefix some pre on transform array T. Okay. You know what? I'm not going to solve this. This is just you're using a algorithm that nobody has heard about. So yeah, this will be my contest. I'll be losing some more rating today. It's alright, I guess. I hope to still be at 2,200. Uh, I gotta get, I gotta do good on Leetcode next time. So tomorrow, I think there's the Repo 5 contest. I will be participating, I think. So yeah, that's it. Um, I'll see all you guys sometime soon, I guess.